Hello students, welcome back to ALPHORES e-learning mathematics classes. Today we are going to discuss the concepts of the relation among arithmetic progression, arithmetic mean, geometric mean and harmonic mean. Today we are going to discuss the concepts about AMGMH, that is relation between AMGMH, right? So basically, suppose if A comma B are any two positive real numbers, then their arithmetic mean is given by A plus B by 2 and geometric mean is given by root AB and harmonic mean is given by 2AB by A plus B. This is a harmonic mean, right? So if it is A, it is G, it is H, then the relation among AM, GM, HM is given by A is greater than or equal, G is greater than or equal, H. That is AM is greater than or equal, GM is greater than or equal, HM. Right? Of course, AGH forms a GP. These three terms form a GP. And also, the equality sign occurs in this inequation, that is A equal G equal H, if the numbers are equal. If the numbers are equal, then the equality sign occurs. That is arithmetic mean, geometric mean and harmonic mean same. Right. Now, coming to the point, the arithmetic mean of finite numbers. Suppose A1, A2, A3, so on, An are n positive real numbers. N positive numbers, then the arithmetic mean of these numbers is given by A1 plus A2 plus so on An by n, right? That is sum of the quantities by number of quantities. Their geometric mean is given by nth root of A1, A2 so on An, nth root of. And harmonic mean is given by n by 1 by A1 plus 1 by A2 plus so on 1 by An. So arithmetic mean of n numbers, geometric mean of n numbers and harmonic mean of n numbers. So same concept is applicable for finite number of numbers, positive numbers, right? So this is AMGMH. Now coming to the next point, that is weighted means. Weighted arithmetic mean, weighted geometric mean, weighted harmonic mean. What is weighted means? Right. Coming to the next concept, weighted means. Weighted means. Right. Suppose A1, A2, A3, so on An are positive reals, right? And W1, W2, W3, so on Wn are any positive rationals. Then A star, let A star is the weighted arithmetic mean, is denoted with A star. Weighted arithmetic mean is given by A1 W1 plus A2 W2 plus A3 W3 plus so on An Wn by W1 plus W2 plus so on Wn. This is called weighted arithmetic mean of n numbers, where W1, W2 up to Wn are any positive rationals, right? And their geometric weighted mean is denoted with like G star, right? Now the geometric mean is given by that is A1 power W1 into A2 power W2 into so on An power Wn whole power 1 by W1 plus W2 plus so on Wn. It is the weighted geometric mean of finite positive numbers. Next, coming to weighted harmonic mean, let it be H star. Weighted harmonic mean is given by W1 plus W2 plus so on Wn by W1 by A1 plus W2 by A2 plus so on Wn plus Wn by An. It is called weighted harmonic mean. Weighted arithmetic mean, weighted geometric mean, weighted harmonic mean. Of course, the relation among these three is again A star is greater than or equal to G star is greater than or equal to H star. Weighted arithmetic mean greater than or equal to geometric weighted mean is greater than or equal to weighted harmonic mean. Of course, equality sign also occurs in case of A1 by B1, sorry, A1 by W1 is equal to A2 by W2 is equal to so on An by Wn are all same, then this equality sign occurs. Right, this is an important point. Next, coming to another important beautiful point, that is Cauchys inequality. The title is Cauchys inequality. These are all inequal concepts. Cauchys squash. Cauchys squash inequality. Cauchys squash is a mathematician name, of course. The inequality, Cauchys squash inequality, right? Before going to the discussion of that point, we are going to discuss a point from vector algebra. After this discussion, we will discuss the Cauchys squash inequality, right? Suppose A bar is a vector A1I plus A2j plus A3k. B bar is another vector B1I plus B2j plus B3k. Of course, these are two vectors. Then we are going to calculate the dot product. Of course, the basic definition for dot product is A bar dot B bar, as you know very well, mod A into mod B into cos of angle between A bar B bar is the basic definition for dot product of two vectors. Because cos theta maximum value is always less than 1. So we are using the maximum value of cos, then the dot product becomes A dot B is less than or equal to mod A mod B. We are using the cos theta maximum value here. So B is less than 1, that's why the result is this one. Of course, basing on this one, we can calculate this value, that is A dot B. A dot B is A1 B1 plus A2 B2 plus A3 B3, right? Is the dot product of A bar and B bar is less than or equal to mod A bar, that is magnitude of A bar. Magnitude of A bar is given by square root of A1 square plus A2 square plus A3 square into magnitude of B bar, square root of B1 square plus B2 square plus B3 square, right? If you squaring on both sides, then A1 B1 plus A2 B2 plus A3 B3 whole square is less than or equal to A1 square plus A2 square plus A3 square into B1 square plus B2 square plus B3 square, right? You know, this is called Cauchys squash inequality. This concept is basing on vector algebra. It is a Cauchys squash inequality where A1, A2, A3 and B1, B2, B3 are any real numbers. So it's always true. This is called Cauchys squash inequality. So I am saying this concept through vector algebra. In algebra, we can say the Cauchys squash inequality in this manner. Suppose A1, A2, A3, so on, An are any real numbers, set of real numbers, and B1, B2, B3, so on, Bn are set of another real numbers. N real numbers, N real numbers, nothing but totally 2n real numbers. Now, according to Cauchys squash inequality, the relation among these given by same manner. A1 B1 plus A2 B2 plus so on An Bn whole square is less than or equal to A1 square plus A1 square plus A2 square plus so on An square into right B1 square plus B2 square plus so on Bn square, I am writing again this inequality in this manner. A1 B1 plus A2 B2 plus so on AN BN whole square is less than or equal to A1 square plus A2 square plus so on AN square into B1 square plus B2 square plus so on BN square. It is the Cauchys inequality in algebra. Of course, this is same as this one. This is the finite number of real numbers. This is the finite number of n numbers. So Cauchys inequality. So remember this result. Of course, it is easy to remember the concept in this manner. That is through vector algebra. So this is Cauchys inequality. So it is a useful result in our progression chapter. Next, coming to the another point, right? As we are discussing the relation among AMGMH is AM greater than or equal to GM is greater than or equal to HM. Now we are discussing about this inequality. AM is greater than or equal to GM. This result is useful when sum of the numbers is given. Then you can calculate the maximum value of their product. That is, once again the statement, when sum of the numbers is given, then if you want to calculate the product of their maximum value, then it is used to calculate AM greater than or equal to GM. I will give you an example. Suppose when x comma y comma z are three real numbers, three positive real numbers, belongs to positive real numbers, right? You are given their sum, that is x plus y plus z is equal to some 3 or some 4, whatever be the number. Sum of positive real numbers. Sum is given. Now we require x, y, z their maximum. That is, when sum is given, you can calculate the maximum of their product using this concept. That is, by using this concept, arithmetic mean greater than or equal to geometric mean, right? Arithmetic mean of three numbers is x plus y plus z by 3. Sum of the quantities by number of quantities is greater than or equal to geometric mean of x, y, z is cube root of x by z. X plus y plus z is given as 4 by 3. Sum is given. We are calculating the maximum value of their product, that is x, y, z whole power 1 by 3. Or you can write x, y, z is less than or equal to 4 by 3 whole cube. It is the maximum value of this product. So AM greater than or equal to GM is used to calculate the maximum value of the product when their sum is given. Also, it also be used in another manner. When the product is given, you can calculate the least value of this sum. When product is given, you can calculate the least value of this sum. Right? Okay, this is one aspect. And another aspect is, suppose AM is greater than or equal to HM. We are using this inequality. AM greater than or equal to HM. We are using this inequality when the sum of their numbers is given. When sum of some numbers is given, then you can calculate the maximum value of this reciprocal sum. The maximum value of reciprocal sum is calculated in this inequality. If sum of reciprocals is given, you can calculate the least value of their sum. When sum of the reciprocals of some numbers is given, you can calculate their sum, least value of sum. Once again, when sum of the reciprocals of some numbers is given, you can calculate their least value of the sum. Right? And also, GM is greater than or equal to HM. GM is greater than or equal to HM. This inequality is used when product of numbers is given. When product of numbers is given, you can calculate the maximum value of this reciprocal sum. When product is given, you can calculate the reciprocals of this sum maximum value. or you have, if you are given reciprocal sum of some numbers, you can calculate the least value of their product. Reciprocal sum is given, then you can calculate the least value of their product. So every aspect is used in two ways, right? Once again I will explain the first point. When sum of some numbers is given, then you can calculate the product of the maximum of their product. When sum is given, then you can calculate the maximum value of their product. Sum is given, maximum value product. When product is given, you can calculate least value of their product. Their sum, least value of sum. So in the same scenario, you can apply these concepts, right? Now coming to next point, we are going to discuss some models basing on these inequalities. That is relation between AMGMH. We are going to discuss some models on this concept, right? Minimum and maximum values of problems basing on arithmetic means and geometric means, right? Okay. First question. Coming to the first question. If x, y, z belongs to R such that x plus y plus z is equal to 4, then the maximum possible value of x, y, z square is. Here sum is given. You have to calculate the maximum or minimum value of the product. Sum is given. Find out the maximum value, right? So that is, we are using arithmetic mean greater than or equal to geometric mean concept here, right? Problems based on geometric means involving inequalities, right? Now arithmetic mean of x, y, z. I am taking x, y, z as z by 2 plus z by 2. X plus y plus z by 2 plus z by 2. You know, this is z, nothing but, because z square is there in the required product. That is a plus b plus c plus d by 2 by 4. Arithmetic mean. This is arithmetic mean greater than or equal to geometric mean. Geometric mean is fourth root of x, y, z by 2 into z by 2. That is this value is x plus y plus z. That value is given as 4. That is 4 by 4 greater than or equal to fourth root of x, y, z square by 4. By 4 here, right? 4 gets cancelled. That is 1 greater than or equal to fourth root of x, y, z square by x, y, z square by 4. Or x, y, z square is less than or equal to 1 by 4. Or it is nothing but 4, right? It is 4. You know, that is the maximum value of x, y, z square. So when sum is given, you have to calculate the maximum value of the product, then use EM greater than or equal to GM, right? Next, coming to the second question. In the second question also, that is a weighted mean concept. Of course, he also given sum is given, you have to calculate the product. That is product. I am applying the same concept. That is AM greater than or equal to GM, but here the power of P is 3, power of Q is 5 and power of R is 7. That's why I am writing this as 2P by 3 plus 2P by 3 plus 2P by 3. This entire value is 2P plus 3Q can be expressed as 3Q by 5 plus so on 3Q by 5. Right, plus R here 4R is there, 4R by 7 plus 4R by 7, etc. Right, like that up to the terms 4R by 7 terms is the arithmetic mean of 15 terms. It is 15 terms. I am writing the arithmetic mean. E is greater than or equal to, arithmetic mean is greater than or equal to geometric mean. Geometric mean means 15th root of these terms, that is 2p by 3 whole cube into 3q by 5 whole power 5 into 4r by 7 whole power 7. Product, geometric mean. Now this numerator product sum is given as, this is the sum is given as 15. That is 15. That is 15 by 15 is greater than or equal to, here p cube q power 5 and r power 7 by r into right, into 2 cube 3 power 5 4 power 7 by 3 power 3 cube into 5 power 5 into 7 power 7 whole power 1 by 15. Because it is the value is 1, we have p cube into q power 5 into r power 7 is less than or equal to reverse. The fraction is reverse. 3 cube into 5 power 7 into 7 power 7 by 2 cube into 3 power 5 into 4 power 7. So this is the maximum value of this product. We have required the maximum value of the product. Right? It is also based on AM greater than GM. Of course, weighted mean and weighted arithmetic mean and weighted geometric mean concept models. Right? Now coming to the next question. For the third one. That is, if ABCD is equal to 1, where ABCD are belongs to positive real numbers, then the minimum value of this one is required. Here observe that product is given. You have to find out the minimum value of the sum. Same concept, AM greater than or equal to GM, right? That is arithmetic mean greater than or equal to geometric mean concept, right? Arithmetic mean of these numbers, that is a square plus b square plus c square plus d square. You know, these are the 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. That is a square plus b square plus c square plus d square plus etc. Last term I am writing the last term as cd. These are the arithmetic mean 10 terms. Right, is greater than or equal to geometric mean, that is the 10th root of their product. Their product is nothing but ABCD some power, whole power is there. Because ABCD product is given as 1, that is greater than or equal to is always 1. Because ABCD, if you are product all these terms, then you will get ABCD into whole power something. Right, ABCD is nothing but 1 given, 1 power something is 1, 10th root of 1 is 1. Right, now its value a square plus b square plus c square plus d square plus so on up to CD is greater than or equal to 10. Right, we have to calculate the minimum value. You know, it is the minimum value. Of course, here by 10 and it is the 10th power, right? ABCD, a square plus b square plus c square plus d square. Its minimum value is 10, right? Okay, completed. Next, coming to the question, third question, fourth question. In this question, your PQR are all positive reals and 27 PQR is given as 27 PQR is greater than or equal to P plus Q plus R whole cube, and also given as 3P plus 4Q plus 5R is equal to 4. Then the value of this one is required. Now coming to the AM grade, it is an inequality between sum and the product. Sum and the product inequality occurs between AM and GM. That's why we are preferring AM greater than or equal to GM concept here. GM, right? Basing on this one, arithmetic mean of PQR is P plus Q plus R by 3 is greater than or equal to geometric mean, that is cube root of PQR. That is, you know, cubing on both sides, P plus Q plus R by 3 whole cube is greater than or equal to PQR, or P plus Q plus R whole cube is greater than or equal to 27 PQR. You know, here it is given as, that is 27 PQR is less than or equal to P plus Q plus R whole cube. Is the equation 2, it is equation 1. It is greater than symbol, it is less than symbol. That is, suppose if x less than or equal to y and x greater than or equal to y, both are simultaneously occurs only when x is equal to y. X less than or equal to y, x greater than or equal to y is possible only when x is equal to y. Same scenario, by observing this one, P plus Q plus R. Of course, when x is equal to y, this is possible only when here P is equal to Q is equal to R. If P is equal to Q is equal to R, then inequality in these two equations are same. That exists, right? Now, if P is equal to Q is equal to R, you have to find out the P value, Q value, R value individually by using this one. So I am using this one, that is 3P plus 4P, substituting Q in place P in place of Q, that is plus 5R, 5P is equal to 12. You know 5 plus 4, 9 plus 3, 12. 12p is equal to 12 or p is equal to 1. If p is equal to 1, q is equal to 1 or also 1. So therefore p, q, r value is 1. Now coming to our final question is, have to find out the value of this value. That is 8p plus 4q minus 7r is required. That is 8 plus 4, 12 minus 7, that is 5. Because p is equal to r. Right. Coming to the last model. Right. X, Y, Z are positive reals such that x square plus y square plus z square is given as 7. And the value of xy plus yz, xy plus yz plus zx also given as 4. Then the minimum value of xy is required. Minimum value of xy is required. So for that we are coming to the point. Same x, because we requires product am greater than or equal gm concept. Am greater than or equal gm concept. Now arithmetic mean of x plus y plus z is x y z is x plus y plus z by 3 is greater than or equal to cube root of x. Of course. One minute, because we are going to calculate the minimum value of xy. That's why we are grouping these two terms as a single term and it is different. So these are the only two numbers. Now arithmetic mean of two numbers is a plus b by 2, x greater than or equal to square root of x plus y into z. No problem. Right. It is x plus y plus z. You have to calculate x plus y plus z. X plus y plus z whole square is greater than or equal to 4 into x plus y into z. Right. So now we are calculating x plus y plus z whole square. Or expand this one. X square plus y square plus z square plus 2 of xy plus yz plus zx. Zx is greater than or equal to 4 of x plus y into z. X square plus y square plus z square value is given as 7. This is 7 plus 2 times of xy plus yz plus zx is given as 4 is greater than or equal to 4 of x plus y into z. 2 4s 8 plus 7, 8 plus 7, that is 15. 15 by 4 is greater than or equal to xz plus yz. But finally we required minimum value of xy. But there is no xy term here. So adding xy on both sides, that is 15 by 4 plus xy is greater than or equal to xy plus yz plus zx. But this value is given here. That value is 4. That is xy is greater than or equal to 4 minus 15 by 4. That is xy greater than or equal to 16 minus 15 by 4. That is 1 by 4. Right. So this is the minimum value of xy. Okay students, these are the problems based on the inequalities involving arithmetic means or geometric mean, harmonic means. So problems involving means and inequalities. Right, these are the standard models for competitive point of view. Now in the next class we are going to discuss some more models. Thank you.